Hi everyone, welcome back. In this video, we are going to talk about redox half equation. So we will be talking about two concepts in chemistry. The first one is reduction, and the second one is oxidation. So reduction is a reduction in charge of a particular atom, or we can say a gain of electrons. And oxidation is a gain in charge, which counterintuitively is actually a loss of electron. Because if we minus a negative number, we get a positive result. And these two processes must happen simultaneously in a reaction. And we will look at an example. The formation of sodium chloride, table salt. So for sodium, since it's a metal, it will actually lose electron to gain in charge, undergoing oxidation process to become a cation. And it has +1 charge, which means it loses 1 electron. Chloride, on the other hand, exists as chlorine gas in nature, and for each chlorine, it needs to gain 1 electron to become a chloride, an anion, to react with the positive sodium ion. Which means that if we have 2 chlorine atoms, they need to gain 2 electrons in total to become 2 chloride anions. And then we will do something like a mathematical addition like this. And since we have 2 electrons here, we want to make this 2 electrons as well. And the way we do so is to actually multiply the whole first equation by 2. And we will regard the arrows just like equal signs. So on the left side of the arrow, for the products, we have 2 sodium atoms, chlorine gas, and 2 electrons. On the right side of the arrow, which is the product, on the left side is the reactant. We would have 2 sodium ions, 2 electrons, and 2 chloride anions. And we can cancel out the 2 electrons on both sides. So we would have 2 sodium atoms, chlorine gas, will form a 2 sodium cations and 2 chloride. And we can combine the products on the right side of the arrow, which would give us a 2 sodium chloride. And by writing out this redox, reduction and oxidation half equations, these two, and by adding them together, we also completed the balance of this reaction. We will look at one more example, which in this case, we will be using the elements tungsten and selenium. So for tungsten, it's a metal, and it will lose 6 electrons to have a positive 6 charge to form a tungsten cation. For selenium, on the other hand, it needs to gain 2 electrons to have a 2 minus charge to become a selenide anion. And we will again add the two half equations up. And we want to make sure that the electrons on both half equations are the same. So we will actually multiply the second equation by 3 to make this 2 electrons 6 electrons, because 2 times 3 is 6. Again, just like math, on the left side of the arrow, we will have 1 tungsten atoms, 3 selenium atoms, and 6 electrons. On the right side of the arrow, we will have a positive 6 tungsten cation, 6 electrons, and 3 selenide. And we will again cancel the 6 electrons, and we will write the equation down. And by combining the cations and anions on the product side, we would have tungsten selenide. And this equation is also balanced already. So a little summary, when we are doing the redox half equations, we want to first identify the metal and nonmetal and their respective charge. And then we want to write out the redox equation, half equations, with the respective gain and loss of electrons. And we want to do an addition of the 2 equations. And we want to cancel out the electrons. But in order to successfully execute step 4, we need to make sure to balance the electron before the addition, which means we want to make sure that these 2 amounts are the same. And right now they're not the same, so we need to multiply 3 to the whole second equation. And after canceling out, we can just simplify. And no need to balance. That's one of the characteristics